Welcome everyone to my talk about Idiomatic Kotlin. As said, my name is Urs Peter. I have quite a few years of experience with Kotlin, and as announced, I'm a trainer where I help people adopting Kotlin in all stages of their journey, from beginner, intermediate, and advanced. Nice to meet all of you. So I would like to know a little bit more about you. Who of you considers himself a beginning Kotlin developer? Okay, about a third. Who intermediate? Okay, so the rest is advanced. Can you confirm that? Advanced? More or less. Okay, excellent. There is a little disclaimer I have to give you in advance, because parts of this presentation will be to a certain degree opinionated. So if you doubt or if you do not agree, that's perfectly fine. My goal is reached if my content sparks good discussions, or even better, if you try out some of the things you learned today, right away, tomorrow. Okay, so then, let's begin at the very beginning. In the beginning, the JVM was inhabited by many dark programming languages. And the creator said, "Let there be light." And there was Kotlin. And the creator saw Kotlin that it was good. And the creator said, "Let there be a language with an appropriate mix of OO functions as first-class citizens." And there it was. And all the upcoming days, he added more features like beautiful collections with powerful high-order functions, immutable and expression-oriented constructs, and only once he suspended his work for a short time when he made Coroutines. And after 6 days, the creator saw everything he made, and behold, it was very good. And the creator sent Pac-Man, known for clearing impure programming constructs as fast as no other, to lead the programmers stuck with the dark programming languages to the promised land of Kotlin. And the creator ordered Pac-Man to the mountaintop to be with him. But because Pac-Man was away for a very long time, the programmer said, "Let's use Kotlin with the idioms we already know from the dark programming languages." So they started to use variables, even more variables, for loops. Well, worse, nested for loops, and also return statements here and return statements there. Double exclamation marks were seen frequently in their code bases, as were if-else-if statements chained after each other. And poisonous streams were trickling through the code bases. And some even called themselves Kotlin developers by simply auto-converting Java code with ID function to Kotlin. But also, reactive programmers just kept on using their awfully complex reactive constructs. Afterwards, they sat down and committed all that code to Git, where it shames the Git history until this very day. Hallelujah! Then the creator said to Pac-Man, "Go down, because you programmers, whom you brought out of the dark programming languages, have become corrupt." And he handed Pac-Man a tablet with 10 commandments, carved in stone, carved in Markdown, stored on the blockchain for eternal availability, on how to utilize Kotlin as it was originally intended. Well, and the rest is present, because today we will explore these commandments in the hope they will enlighten you and turn your code bases, hopefully, into beautiful gardens of Eden. Okay, so let's get serious. Let's look at our first commandment. You shall favor immutability over mutability. When we look at these few lines of code, we see that Kotlin favors a lot of immutable constructs. Well, we have vals, should be known to all of you. Method arguments are immutable by default too. whenever you create a list, you create a read-only collection of a list, which is kind of close to an immutable collection. And of course, we have our data classes, which allow us to manipulate a domain in an immutable fashion. The question, of course, is what is so good about immutability? Well, to recap, when you have an immutable object, it means that you can have exactly one state, and this state can also not change. Mutability, on the contrary, implies an infinite amount of states. So when it comes to reasoning about your application, when you only have one state, reasoning is definitely simpler, unlike an infinite amount of states. Especially if these states can also change at every point in your application, not only at the spot where it is declared. The same is true for safety. When a state always remains the same, not much can happen, which is not the case for the mutable counterpart, where accidental errors can quite quickly be introduced, especially, for instance, if you refactor your code base, and later on some variable state will be assigned that is not compatible. Immutability implies no side effects, so testability is easy in the sense that you always get a deterministic result. Whereas with the mutable case, we all know a situation probably where you have 3 tests running, and depending on the order they run, they succeed or they fail, which most of the time implies a certain amount of mutability. Last but definitely not least, when you do things immutable, well, everything is set safe out of the box. Whereas in the immutable case, you have to do synchronization yourself if you don't forget it. Otherwise, in production, you will have to do nasty debugging. And synchronization also comes with a performance penalty you have to pay. So these are quite a few benefits. No wonder that Kotlin embraced the immutable paradigm and made it kind of very accessible to you. What does this mean for your daily programming practice? Kind of evident, always start out with using whiles, not wars. Especially things like dependencies of your objects. There's no reason why such dependencies can change, make it a while. Whenever you use a collection, ask yourself twice whether you use a mutable one. That's why you have list of. There's also a reason why Kotlin put the prefix mutable behind this construction method of the mutable list, to make you aware that, are you really sure you want to use mutability? Whenever you deal with domain logic, of course use your data classes, which allow you to still change your domain logic, change your domain state, but each change will result in the object. And some might say, okay, does it not have performance implications? In all the years I've created Kotlin applications, I've never had any performance issues because of that. Performance issues I had normally with other reasons. Database connections, slow endpoints, and so on. But maybe the nanosecond it costs to make a new instance doesn't really count. Well, then the question is, if mutability is so bad, why do we have it then in the first place? Actually, mutability is not an issue as long as you do not leak it out of a certain context. When we look at the standard library of Kotlin, we see that many of these higher order functions or collections use mutability in one form or the other, probably out of optimization reasons. So when mutability doesn't leak, it's fine. Which doesn't mean that you have to use it, you still could use a more functional approach to achieve the same, which use recursion here in combination with tail recursion that allows you not to blow your stack. So, null safety, of course, is the feature that is most loved in Kotlin. I think that's still the case, especially if you come from other languages. That's kind of a revelation that gives you a lot of safety. Of course, there's also a need to work around the good defaults, which is exclamation mark, and as you might know, there is a synonym for exclamation mark, which is bang bang. There's of course a reason for that. So be aware, whenever you use bang bang, a unicorn dies, for one, and second, you might run into null pointer exceptions, which is a recent addition. Before it was Kotlin null pointer exception. So what can you do instead? Provide, for instance, a sensible default, like here the empty list, or throw an exception with a meaningful text, so you know why this variable was null, even though you would not have expected it to be that way. Especially when to interact with Java libraries, you might run into the situation where you get different nullability concepts like optional in Java. And it's probably not a good idea from a uniformity point of view to mix the two. That's for one. And for second, you also won't have the ability to leverage, for instance, the smart cast features Kotlin offers. So an easy way to work around that is simply call the or else return null, and then you converted this nullable construct into a nullable construct that is native to Kotlin. Well, overusing immutability is a good thing, isn't a good thing either. Why? Because whenever you introduce a nullable construct, you also introduce somewhere a condition to check whether it's null or not. And if you can minimize that, your code gets simpler. So only where it's really needed. Assign defaults. And when it comes to collections, it doesn't really make sense to use nullability because the collection itself is a kind of nullable construct that can have a value, a filled collection, or no value, an empty collection. So in my practice, 99% of the cases, using collections without nullability perfectly works fine. Always use nullability? Well, there's also an exception to the rule, of course, otherwise there's no rule. Here we have a classical case of late initialization, so whenever our application bootstraps, then the onCreate method would be called. So we can be kind of sure that the catalog is available once the application has been bootstrapped in a correct manner. So here, late init var is probably a better approach, preventing us from always checking whether this catalog is null or not in all the code we're using. Okay, get the most out of classes and objects. We already talked about whenever you have a domain, then of course you use data classes. And I don't know if you knew that, you have the JVM record annotation. So should you use this stuff from Java, then you could use it in Java as a record class, which can be kind of nice for the Java people. On the contrary, when you have class that process stuff, do not use data classes and use the companion objects as they're intended at the end of the file, where you put in all the static stuff. And also annotate it if it needs to be used by Java, otherwise the Java folks have to use person service dot companion dot to access these features. Well, I think that's kind of straightforward. Most of you know that, but maybe not everyone knows that you can add a lot of expression to your Kotlin domain with a nice trick, which you do not have in this particular case. So here in this login method, we use common types like string. And what happens, for instance, if you mix the two arguments? So password first, email last. Well, you won't log in, but say if you also log that user with email X couldn't log in, then your password is locked. That's probably not what we desire. Kotlin has a very simple feature which I haven't seen being used often, which are value clauses. Who knows value clauses? Quite a few. Who uses value clauses? Less. Okay, but still a few. Well, great, cool. So value clause, what is it? It is actually a simple wraparound a common type, which is only available in your source code, not in your bytecode. So in your bytecode, it's like type erasure, it's gone. So it comes without performance impact. And by using them, first of all, we get safer code and more expressive code, like you can see here below. There is a reason why top-level methods and arguments are called top-level, so don't wrap them in object. And as said, if you want to access them still from Java, then you can use this annotation, which allows you to access them with timeutils dot. In some cases, you have exhaustive branch checks. So in this case, it's kind of annoying that we have to have this else case we have to provide, or we should provide, which probably will never be called. The remedy here is simply to use sealed interface or classes, which then makes the when check aware of, hey, I've checked all the possible conditions, similar like enums, and we are fine. Okay, so this is a bit more or less the basic stuff, so let's move on and try to embrace a bit more advanced constructs. Whenever you write code like this one on the left, which is probably copy-pasted from Stack Overflow in Java and then pasted into Kotlin, most probably haven't really seen what kind of awesome extension functions are available within the Kotlin standard library. Especially for I/O, Kotlin offers a great variety of extension functions that make this piece of code really a snap. Don't use stream. Why should you? It's overly complicated, it has this ugly collect step, all these conversions from one to another. Not necessary. Simply use the Kotlin higher order functions, which are all, by the way, extension methods. Every library out there, Java library out there nowadays that takes itself a bit serious has also some Kotlin extension wrappers to make the library to be used in a very idiomatic way. Same is true, for instance, for checksum, where you have these reified type additions so that you can, for instance, here serialize a value simply by offering its type, and you do not have to wrap it in this ugly type reference thing. And of course, testing. I still see people using assert equal stuff and assert true, because assert true is actually the only thing if you want to check things a bit more advanced. Why do that? There are great testing libraries out there, like CodeTest, where you can put all your assertions in a very expressive way. So very readable, maintainable, and so on. If you haven't done it, have a look. It will be, it will spice up your tests tremendously. Well, these are extensions that are existing, but how about extensions in your own code? How do you deal with them? Whenever you have to extend third-party classes, like for instance local date time, then I would say use extensions. And there are two reasons for that. First of all, it makes your API more fluent. And second, you also get your extensions in code completion, which is not the case when you use the simple utility method. There is, of course, a gray area when you use extensions or bind the code directly to the implementation. One way to use extensions definitely is in this particular case. So say you have a domain space and a DTO space, and you have to convert from one to another in our application to make things work. Well, if you bind your conversion code to, for instance, the DTO or the entity, what you get is circular dependencies, which of course you want to avoid. So here we try to scope a certain conversion from one to the other, and what can better fulfill this job than extensions, which for instance we could put in a service package where these conversions really take place. Whenever we want to make APIs more fluent, or even for DSLs, the extensions are a great way. So here we try to add some URLs to this wallet with this kind of ugly construct. With some extensions we can make this code very intuitive. And also here the question is, do I use extension methods or put it in the class? I would say if the DSL is the core responsibility of your package, then put it in a package. But most of the time you want to add some nice API sugar, for instance for testing purposes, which is then only used again in the testing scope, so there it makes sense to put this functionality in extensions rather than in the original implementation. Okay. The next commandment is about when to use when. So when not to use when is when you have only two conditions, right? So why should you use when? It's 4 lines of code versus 2. No need to do that. And of course, if you have multi-branch conditions, then when is the way to go. Which is of course more readable, and you have this else case you need to cover, which in if else is a bit up to you. Same is true for these enums. Another else case which is not needed, it can be omitted. I hope he agrees too up there. He stopped, so it's going to be fine apparently. Okay, so I think now I would say we touch on the more interesting stuff. Commandment number 6 is the commandment that made me, to be honest, really a better programmer. That's where I started to grow. It took quite an effort to go over the threshold, but once you've taken it, you definitely will be rewarded. So what am I talking about? You have in that sense 2 ways of programming. Imperative programming, which actually implies using a lot of variables, which you then mutate along the way, right? So you think in concepts of loops, mutable collections, vars. And on a higher level, it's about side effects, mutating data. The contrary is expression-oriented programming. It's not necessarily functional programming. The functional one is probably one step further, but it definitely relies on functional thinking in the sense that you think in input and output. And every output will actually be the input for the next computation, as we see here in this simple example. Something goes in the filter, something goes out, and based on that we continue our process. So we more think in terms of transforming data rather than mutating data. Using these constructs, high order functions, val, read-only collections, and so on. The presentation we just saw before, you saw that that apparently comes from Scala. Kotlin favors these kind of expression-oriented constructs quite a lot. So why is this better? It's better in the sense that you get conciser code because your intent is stayed clearer. It's more deterministic because you always have some output and you can check output. And because you have output, you can test things. When you don't have a side effect that maybe even removes your file system, it's kind of hard to test. Whereas with a return value, that's easy to accomplish. What you also get is a better scoped code because the only thing that actually the function does is what it returns in its value. That's what happens. Whereas in a side effect, you simply don't know. So the scoping is also lost. And definitely last but not least, it's easy to reason about. It's not only good for yourself, but also for your teammates. So let's see what Kotlin offers us with that regard. And as I said, we've already seen certain parts of that. If else is a expression, when is an expression, and try catch an expression, and by now everyone knows that because you've seen it twice, so use it, don't forget it. And when you start embracing this way of programming, what you also will see is that you will not use return many times anymore. Because in return also implies that you do some processing, and then you've reached a certain condition, and then you just return the thing. Whereas when you more think input, output, it's just calling functions that call functions, and off you go. Closely related to expression-oriented programming is using function collections or for loops. Using function collections has quite a few advantages. First of all, you actually program on a higher abstraction level, because here we say that our intent we try to achieve is filtering. Whereas on the left you just do some processing and have to figure out, oh yeah, this person, he's filtering. But on the right, you tell it explicitly. So that's a big advantage. Besides that, these high-level constructs are very well tested, so your code is less error-prone. You can change this computation. And that's actually where maybe a tip can help, in the sense that when you have multiple of these transformations, it's a good advice to put them top-down instead of left-right. It's very simple, but it really increases the readability in a tremendous way. Well, and then of course you have situations where you have these hundreds of transformations, which also doesn't really make your code that readable. And a good idea here is just to introduce intermediate variables where you name explicitly certain results. Also make use of destructuring. That's what you do here, to name certain lambda arguments. So instead of first and value, it's now group or age group, which gives a bit more semantic to what we are processing here. And so my heuristic is more than 3 to 5 operands. It's maybe good to think about to introduce intermediate variables. So, commandment number 8 is probably a language feature you won't use in the first week of Kotlin, maybe also not in the first month of Kotlin. So who of you uses scope functions? Okay, so it's about less than half, about 40%. Okay, so for the ones who don't use them, what do scope functions do? Or what do you get without them? You get this piece of code, which is very traditional, right? You declare a variable, then you call some setters, assuming some mutable Java client you have to configure in this way, and then you return the variable. Kotlin has these scope functions which provide you with the object, like here, REST client, implicitly in the scope of this code block. So username secret URL refers to the instance of REST client. So here we have a clear boundary where we start configuring the object and stop configuring the object. Instead of having this variable that, well, it's still available also when the object is already configured. This becomes even more clear if we have this particular case where we have this file, and then we set some state, and in the end we want to know whether the file has been created or not, which is a boolean. Here we could use run, which is, by the way, a weird name, but it's almost the same like apply, with the single difference that it returns the type of the last statement, which is a boolean here, instead of the object itself, like in the apply case above. And the nice thing here is that we do not leak now our file variable into the rest of our code. So file is kind of isolated from the rest. The only thing we care about is the returning boolean we probably need to continue our process. And by doing so, we clearly isolate certain things in our code. You could also make a private method, but private methods, if they're named nicely, that's a good thing, but they're still kind of disconnected of your main logic, and for 2 lines, is it worth to make a private method? So then I think scope functions can add a lot of value. Counterpart of run is let, as we'll see, so you could use if-else to do a transformation on a type, a nullable type that is not null. I think let here is a good approach. Question mark let, then you get access to the real value, and then you do the transformation. Sometimes you still have side effects in your code. Hard to do without them. Again, this is very traditional. We have an error assignment and we do stuff with it. But how about coding it that way? Simply use a precondition check function, then simply tell the message you want to be thrown in your illegal argument exception that required us, and also log it. So it makes it very explicit too. Okay, well, commandment number 9, embrace coroutines. So let's look at what happens if you do not embrace coroutines. Well, then you have to choose a reactive toolkit, and once you've chosen a reactive toolkit, then you're really stuck to the abstractions in this particular reactive toolkit. So in this case, it's Mono from Spring Reactor, probably the one some of us know best, which goes viral in your whole code base. Besides that, we get burdened with these awfully complex combinators, normal language constructs like if, else, and the like you cannot use in many cases. Like here, switch if empty needs to be used if this mono has been empty. You have to know that, so steep learning curve. And everything needs to be wrapped in a mono. So also no throwing of exceptions, it needs to be wrapped. And now think of this code not only in the control layer but throughout everything. Who uses reactive toolkits, by the way? Not many. Okay. Well, it might be that once, okay, just to kind of round up my point here, what actually I personally think is the worst by using reactive toolkits is that your business intent is getting lost. Your code is more about these reactive abstractions like this mono than what this code should be from do from a business perspective. Amen. So, can coroutine help us there? Well, I would say yes. So the only thing you have to do is mark your methods suspend, and of course you need either a reactive toolkit on the bottom, like Spring Reactor, with some glue code that converts these reactive abstractions to coroutines, which is a very thin layer, or use a framework that has coroutines out of the box, like Keytor. Then what you have to do, if you're stuck with some services, DAOs that still use these reactive abstractions like monos, you have these excellent extension methods that do these conversions from the reactive abstraction to a suspend function. And then you can simply use the types you normally use also in your blocking program. So no additional abstraction involved. On top of that, now all of a sudden we can use normal programming constructs like if, else, throw, just the constructs we are using. So in that sense, this code almost looks like blocking code, even though it has the characteristics and also performance benefits we get when we use a reactive toolkit. But that's not the only benefit. You might have heard of project Loom, which is expected soon. And soon is not really smart, it's already waiting years for Project Loom. So what does Project Loom do? It actually, it's probably the most most crucial change to GVL on the go once it's there, since its existence. Because what it does actually implementing coroutines into the GVM, so that it's really a kind of a native feature of the GVM instead of what Kotlin does, making the language feature which then runs on the GVM. So we cannot then actually execute any blocking code anymore as long as we use this virtual thread, which is a counterpart of coroutine. Even so, it feels for us as if we execute blocking code. But then the GVM will make sure that this is handled in an asynchronous fashion, which is an awesome thing. But of course, might still take some time till it's there. They extend the delivery line more and more, so I hope you'll still encounter that. But once it's there, and you have chosen for coroutines now, I think then you're definitely future-proof, because the one thing you probably have to remove is the suspend keyword, and everything just keeps on working. Whereas, if you have chosen for Reactive Toolkit, you are fed with this great amount of complexity, which is simply good for nothing. Okay, which brings me to commandment number 10, which is kind of synthesis of all the things I talked about. So let's see if we can apply the things we learned on this snippet here on the left, which is set up in a more traditional programming style, imperative, mutable, and so on. So we deal here with monos, mutable lists, vars, loops, a lot of checks because of the vars, side effects, another var, where is it mutated? Okay, apparently it's if else. Have we forgot one? So let's see if we can do better. So this is the snippet here you've just seen in the slides. Let's copy paste that and you call it Idiomatic. And the first thing I want to get rid of is this mono, right? Should be quite easy. And because I really like to embrace this expression-oriented programming, I use an equal sign rather than curly braces. Let's see how this will end up. Let's assume we have to reuse this find advent of code developers per year. That's what we do, and then we filter out the highest score developer and see which programming languages have led to a high score. That's actually what we try to accomplish here. And well, this returns a mono. So how can I get rid of the mono? Well, as just said, use one of these extension methods like await single, which turns this method into a suspend method. And IntelliJ helps me with that in the sense that also my surrounding method needs to be a suspend method. Okay. I could assign this result to a val, perfectly fine. I like the more scoped way of doing things, saying let and give devs a meaningful name so I know I'm dealing here with devs. So what is happening next? So here we apparently do some precondition checking. And because we have monos, we can't use require, right? Because when you use exceptions, you're in trouble. So we say require, devs is empty, and here return our string method. Let's return our string in case something goes wrong. For which we also say, let's log the thing. Logger dot error. Okay, so our precondition check has been completed. Let's do a to-do, because otherwise you have so many errors we see later we remove it. Then we do the real process. And apparently we loop here through stuff, and then we do some if. Well, that's filtering, right? So why not just name it that way? Filter it.score greater than 1000. And then we do this side effect thing here. Well, that's partitioning, right? So why not use a word that exactly does that? Partition it language Kotlin. For further processing, we need access to these two collections. So again, we could say, could do an assignment or continue processing with let. And now things get a bit ugly in the sense that my input parameter now has become a pair of lists, with two lists. Which list is what? Well, let's do some destructuring to help us identify what is what. And then we do this kind of if-else juggling. And of course, when multiple if-else conditions are checked, you're better off with a when expression. That's what we do right here. When, because of time, I have to hurry a little bit. Well, so we've created actually our resulting string. Do we have to assign this to variable? No, I think it's kind of readable just to have it that way in your code. Then we have to return this tuple where we have to calculate the max score. Also here, let as higher order functions help that max by score, and off we go. So we not only reduce the amount of code from, let's say, 31 to 11 lines, I guess. We made also way more clear what kind of intent we have, so we filter your partitioning. We use these name variables to clearly identify what we're resulting with. And when your code base starts to look more like that on a larger scale than that, I definitely assure you that programmers will be happier to work with. At least that's really the experience I have. Which brings me to the conclusion of this talk. So, should you use many of these mutable and imperative constructs, I advise you throw them in the waste bin for at least 2 weeks and see what happens. The chance is very high that you will see the promised land and unleash the true power of Kotlin. May Pac-Man be with you.